Hello mathematicians, puzzlers, and other curious people. We are here to put the next step in our beach pictures, which is we are going to put some seashells in the sand. So those seashells are going to come from a circle, not this circle where you use 2 points to define it, because that would have some different effects than what we want. But I'm going to click this More menu. Yours might look a little different from mine, but I'm going to look through my menu of different construction tools until I find a particular kind of circle, and that's a circle with a center and a particular length of radius. So I'm going to click a point for the center, and I'm going to try out what happens when the radius is 4 units long. Okay, so I notice this is overlapping onto my picture. I'm going to end up moving that around anyway, so I'm not really thinking very much right now about where that is. But I'm going to scoot that up so I have what feels like a little more room to work with. And then I'm going to drop some points around the outside of this circle. Now I'm being careful to make sure that I'm pointing at the circle when I drop them, but I'm not being particularly careful with where they are except that they end up on the circle. Okay, now I'm going to draw a polygon using those points, and I'm just going to pick one point to start with, and then just go around the circle. So I'm not going to do any weird doubling back stuff. The next thing I'm going to do is come to the segment tool right here, and from one point I'm going to draw segments all the way across the polygon to the far corners until it's cut up into triangles. Now one thing I notice is that this corner and this corner are already connected to the corner I'm starting from, so I don't need to draw segments connecting them. Now the important thing about how I did this is I can move this point around and the whole polygon moves with it and doesn't get distorted. But I can also move these points to change how the polygon looks. So you see how it gets kind of a seashell appearance when one of the points is fairly far from the others. On the other hand, that doesn't really look as much like a seashell. So you can move those points around however you want to. It also doesn't look right if you rearrange the order of the points. It gets that weird crossed up appearance. So don't do that. And then when you're ready, you can move your seashell out to the beach. Now one thing you might notice is that this seashell looks really big in comparison to that beach. So one thing you might want to do is come into this menu and find that circle. Let's see. There we go. Circle with center I and radius 4. We can change that radius from a 4 to say a 2. And it just scales down nicely, and it keeps those points mapped out to where it seems like they should be. So it sort of shrinks fairly consistently instead of it being just completely wild. Now if you feel like it looks a little different at the different scale, you can still move things around to fine tune. Let's see, and then you can drag that to the beach. I'm still going to make it a bit smaller, so I'm going to come back to that circle, and I'm going to change the radius from 2 to 0.75, so 3/4, and that makes it just a little seashell. Okay, and then I'm going to hide all those points. And the circle and the center point. Now if I decide I want to move that around, I can show the center point again and move it around to over there or over there, anywhere I would like to. I can also make other changes to the appearance of the seashell. So I can come here to the polygon and click on its settings and I can change, say, the color. So maybe I want this to be sort of a light blue seashell. I can turn that opacity way up. Maybe more green than blue, like that right there. Yeah, I like that color. And I can change those lines to something that will match it more closely, like that. So some of you might be wondering, where's the math in all this? You know, we're using a lot of shapes, but we haven't really done any calculations except for working with what number we used here. It turns out these seashells are an important step in showing how a certain formula works. So I'm going to show you that now. So there's a formula that helps us with calculating the inside angles of any polygon. So we can draw any polygon we want to. Let's see, that has 1, 2, 3, 4, 5, 6 sides. Well, there's this cool formula. The number of sides minus 2 times 180 degrees equals the total number of degrees in the triangle. Or sorry, the polygon. So in the inner angles. Sorry, triangles on the brain there. So sides minus 2, well, the number of sides was 6. So 6 minus 2, and then times 180 degrees. Okay, well that's 4 times 180 degrees. Let's see, 180 times 4. I know 200 times 4 would be 800, so I'm expecting a bit less than 800. 0, 32, really 320, 4, really 400, and 3 would be 720. That's a bit less than 800, so that's believable to me. So that tells me that if I took a protractor and measured all the angles in this hexagon, that's the name for a 6-sided polygon, that I would find out that there are a total of 720 degrees. Now, this was a really sloppy drawing, so it might not come out perfect, but that's my fault for how I drew it, not the formula's fault. If I used a straight edge and did this really properly, it would come out better. Why does this formula work, though? So the reason this formula works is the exact thing I showed you with the seashells. So if we start from that corner, well, we've got, I'm going to use blue to label the triangles, 1, 2, 3, 4. So we've got 4 triangles that can be put together in that way to make up a hexagon. And all those angles of the triangles would combine to make the angles of the hexagon. Well, why are there 4 triangles, though? Does it have anything to do with the number of sides? Yes, it does. So it turns out that the number of sides on a polygon is exactly the same as the number of corners. And it's not difficult to see when you think about it why that would be the case, because 2 sides come together to make a corner, and each side has a corner at either end of it. So let's take a square because that's a nice, easy example. I'll try to draw a square anyway. It might be a little different from a square. It's close to a square. So each of these corners is made by 2 sides, but also each side has 2 corners that it's part of at each end. So the number of corners and the number of sides has to always be the same. So really what we should be saying here is corners minus 2, because then we can see that, well, okay, so I'm going to erase a few things so that we can focus on what we're really looking at here. Sometimes you need to tidy something up. If this were GeoGebra, I would just use that hide button. Okay, so here's what I see. If we have 6 corners, 1, 2, 3, 4, 5, and 6. Okay, well, we're going to draw 3 extra segments to connect 1 corner to all of the others. And those 3 extra segments divide the interior into 4 triangles. Why was it 3 extra segments? Well, because this was already in there. This was already in there. So the number of corners that were not already connected to our root corner was 3 less than the number of sides. But then we had to add 1 back on for the fact that the third of them made 2 triangles. So the number of corners, which is the same as the number of sides, minus 2 tells us the number of triangles. Now what about this 180? Well, it's just a geometric fact, which I'm going to ask you for the moment to just believe me on this, but there's a good reason why this has to be true too, so I'm going to make another video about it. But it's a geometric fact that the 3 corners of a triangle, if you add them up, that's the Greek letter capital sigma, often used for a total or a sum in mathematics. If you add those all up, their sum always, if you're on a flat surface, equals 180 degrees. So this picture that we made in GeoGebra is the foundation for the proof of an important formula that's often used in engineering and design and all sorts of things. So of course, very few beaches have only 1 seashell. I'm going to leave it up to you how you want to design the rest of them. For the moment, though, I'm going to just go ahead and give you some time to work on this. I'll be posting another video tomorrow so that we can see another step in making this picture. Well, really these pictures, because they're going to be different from each other. So for the moment, I'm just going to say I'm Avrila at Math with Avrila, and I will calc you later.